Hey everyone. Came across this quote, actually heard it on a commercial and thought it was just perfect for kind of what is going on with us right now. Tough times don't last, tough people do. And I know we're all going to get through this. It is rough, both from a e-learning standpoint and just kind of everything going on in the world, but we will get through this. So we're going to press on with our trigonometry unit, and we are going to talk about special right triangles today. So there are some notes posted and then homework that'll be submitted as well. And if you take a look, there's a warm-up at the top. So I actually want you to pause this video, do the warm-up, and then come back and I'll give you the answers and we'll kind of check through that. Okay, welcome back. So hopefully, as you did that warm-up, you would have drawn in the triangle initially. They told us that angle A is the right angle, so that has to be this one. The other two don't matter. We'll just make this B and C. And since they told us the sine of C was 5/13, we're looking at this angle here, and sine is opposite over hypotenuse. So 5 and 13. By doing Pythagorean theorem, you would have done 5 squared plus whatever this side was equals 13 squared. You end up getting this to be 12. So then when you find the tangent of B, so looking at this angle, opposite over adjacent, you get 12/5. Doing the same thing with number 2, we have a triangle there, and it says U is the right angle, and it's cub. So if the sine was 1/2, sine is opposite over hypotenuse. So opposite is 1, hypotenuse is 2. Pythagorean theorem, you end up getting this to be the square root of 3. When you find the cotangent of angle B, you get 1 over the square root of 3, but we can't keep the square root in the denominator, so we would have to multiply both sides by square root of 3 over square root of 3, and we would get an answer of square root of 3/3. For number 3, this missing side ends up being 7, doing Pythagorean theorem. And these ratios are 24/25, 25/7, and 7/24. So hopefully you were able to take a look at that, message me with any questions. And as we look at our new stuff today, special right triangles. So the first one, we know all three angles add up to be 180 degrees. So this missing one has to be 45. And if we think back to geometry, when these two angles are the same, that means these two sides are the same. So if this side is 3, then this side has to be 3. So we can do Pythagorean theorem to find this missing side, we'll say is C. 3 squared plus 3 squared equals C squared. 9 plus 9 is 18. Square root, we're looking at the square root of 18, which is the square root of 9 times the square root of 2, so 3√2. So our missing side is 3√2. Doing the exact same thing with this next one. That missing angle is 45. These two sides are the same, which means that has to be the same. When you do Pythagorean theorem again, you simplify this side to equal 4√2. So what do you notice? Is there a pattern with 45, 45, 90 triangles? One observation you should have are the legs of the triangle are the same length. They're congruent. So we had a 4 and a 4, we had a 3 and a 3. Those are the legs of the triangle. The hypotenuse was always the leg, then times the square root of 2. If you look over here, we had a 4, and then that was a 4 root 2. We had a 3, and then that was 3 root 2. That's not a coincidence. That happens every time. So the leg times the square root of 2. So that pattern works out every single time for a 45, 45, 90 triangle. So that's something we have to keep in the back of our mind. The other special right triangles are these. So if all three angles add up to be 180, we end up getting this missing side to be 60. Pythagorean theorem to find that missing side, I'll call it B. When we subtract the 3 squared from the 6 squared, we get 27. And the square root of 27 can be broken up as the square root of 9 times the square root of 3. So 3 root 3. Doing the same thing over here. So that's a 30, because they all have to add up to be 180. When we square this side and this side to equal our c squared, so 2 root 3 squared is going to be 4 times 3, because 2 squared and then the square root of 3 squared, and then we have our 2 squared here. So we're actually getting 12 plus 4. So c squared is 16, making this 4. This one's kind of a trickier pattern to see, but do you notice anything between the legs and its corresponding angles? What you should notice is the leg that is opposite of the 60-degree angle, so in this case 3 root 3, it's going to be this number opposite of 30 times the square root of 3. If you look over here, opposite of 60, it was 2 root 3, it was this number times root 3. So the leg opposite of 60 degrees is equal to the leg opposite 30 degrees times the square root of 3. Then if we look at the hypotenuse, this was 6, which was twice as much as this one. Over here we got 4, which was twice as much as that. So that pattern is the hypotenuse is equal to the leg opposite of 30 times 2. Those are the patterns that we're going to have memorized for solving special right triangles, because we're not going to be given enough information to be able to use Pythagorean theorem. We just did Pythagorean theorem in order to kind of develop what this rule is and see that pattern. So if we look at these, I'm actually going to make a change in the beginning here. Instead of making it x, make these x's s's, only because we have different variables in problems that we do that use an x So I'm going to actually call it S because that was a bad S. So over here we had S root 2. Over here we had 2S, S root 3, and S. So we're going to just stick with that as being our kind of rule or pattern. So we're going to be given triangles, and we have to figure out what each of the other missing sides are based on those triangles. So if we look here, 45-degree angle, so it's a 45, 45, 90. We know these two sides are the same. That makes W a 4. And then the pattern is the leg, then the leg times the square root of 2. So that means this one has to be 4 root 2. So no solving necessary for that one. For the next one, it's a 30, 60, 90 triangle. The side that they gave us was opposite of the 90. If you look at the pattern, the one opposite of 90 is equal to 2S. So in some ways, that means 2S is equal to 10. Well, divide both sides by 2, and you get S to be 5. Well, S is always opposite of 30. So that's telling you opposite of 30, in this case W, is equal to 5. Opposite of 60 is always S root 3. So we're taking our side of 5, and now this becomes 5 root 3. Looking at the next one, it's a little trickier because they didn't give us one of those easy sides. They gave us the side opposite of 60. Opposite of 60 is S root 3. So we're dividing both sides by the square root of 3. So we're getting 18 over the root 3. And that's what our S is. We can't keep that in the denominator, so we're going to have to multiply both sides by the square root of 3 over the square root of 3. You get 18 root 3 over square root of 3 times the square root of 3 is square root of 9, which is 3. 18 over 3 simplifies, and we're getting 6 root 3. So that's saying the side opposite of 30, in this case x, is 6 root 3. The side opposite of 90, our rule says it's 2s. So we double our 6 root 3, and this ends up being 12 root 3. So a couple of patterns there. They can be a little tricky at times. Take a look at those. Message me with any questions. And as always, have a good day.